Okay, well, and welcome everyone. So in this video, I'm going to go over the last couple exercises on the second exam's problem set. So these are going to be a bunch of innovation exercises which show how you can take a market that's currently competitive and make it a monopoly. And then I'll think about the relationship between elasticity and monopoly. All right, so first, the inverse market demand for MP3 players is given by P is equal to 240 minus 2Q, which is a cool example now that we don't have MP3 players. So, all right. The market is served by two firms, A and B. Initially, both produces at equal unit cost, C naught. Find the price that each should set if they compete as Bertrand firms. Now suppose one invests heavily in R&D and reduces its unit production cost to 40. Find A's new monopoly price and quantity. For what values of C naught will we consider this to be a major innovation? And we'll just continue on. All right, so we have a bunch of firms. We got two firms, and initially they have the same unit cost. What price are they going to set if they're competing as Bertrand firms? Well, Bertrand competition means that they're competing in price. Here we'll just assume that they have identical products. So we're doing identical products Bertrand. And that actually has the same prediction as the competitive market. They'll set price equal to marginal cost. Why? So Bertrand predicts price is going to be equal to C naught. Why? Well, higher prices would be undercut by your rival. Lower prices would lose money. If both set prices above C naught, each would have a dominant strategy to undercut the other. And this logic forces the price down to marginal cost. So the idea would be you got two firms. One decides to set, they both have costs of $2. One decides to set the price of $3. What's the other firm going to do? They'll set a price of $2.99. Then the other one sets a price of $2.98. $2.97, $2.96 until the price crashes down to marginal cost. Suppose now one has lowered the cost to 40, right? Now we don't know what they started at, but we know that they lowered cost down to 40. Let's find the new monopoly price and quantity. Well, to find the monopoly price, we need to get marginal revenue. So marginal revenue, we're going to begin with the demand curve. Marginal revenue has the same vertical intercept and twice the slope. So it's going to be 240 minus 4Q is marginal revenue. So if the demand curve is 240, down to 120, and then the marginal revenue curve has to be 240 down to 60. So marginal revenue, the output corresponding to where marginal revenue is negative is going to be the midpoint of the demand curve. That's why I put this 120 here, because this is corresponding to the midpoint of the demand curve. That's also where demand is unit elastic. All right, the other way you could see this, like how do we know that the marginal revenue is going to be twice the slope at the same vertical intercept? Well, you could actually write out revenue. So revenue is going to be price times quantity. Replace the price with 240 minus 2Q. So you'll have quantity, you have Q times the quantity 240 minus 2Q. Distribute, you'll have 2 times 240 minus 2Q squared. Take a derivative, because what we just talking about was total revenue. Take a derivative, and you'll have 240 minus 4Q, and that's marginal revenue. All right, so marginal revenue is going to be 240 minus 4Q. Marginal cost is 40. So solving, we find the monopoly's quantity would be 50, and the monopoly's price would be 140. Right? So what would be the new monopoly price and quantity? Quantity of 50 and a monopoly price of 140. All right, so that's this right here. The monopoly produces where marginal revenue equals marginal cost. We go up to the demand curve to find the associated price. For which values of C naught would this be a major innovation? Well, the major innovation would require that cost has fallen enough for this firm to capture the market and set the price as a true monopolist. So we would need, given that the costs have gone to 140, we would need that the initial costs, the cost that the other firm is able to compete at, are at least 140 plus epsilon, something higher than 140. Otherwise, we would not be able to successfully undercut this rival as a monopolist, because suppose the initial cost was like 120. Now, even though our monopoly price is 140, if we try to set the price of 140, we're not a true monopoly because you've innovated, but this other firm is still there. So they would be able to just keep their price at 120. All right. Suppose, for example, the initial price was 100. What's the optimal pricing decision after they've innovated? Well, we have much lower costs, but we can't price like a true monopolist. We're going to have to set a price at like 99 or like 100 minus epsilon. So my comment, the innovation reduced the monopolist costs, and it's good for them. However, the monopoly price lies above the competitive price. This means the monopoly cannot behave as a true monopolist. Instead, it does the best by pricing just below the competitive firms. By undercutting rivals, it's able to serve the entire market. It's not able to enjoy full monopoly profits. Oh, the history of these. So I wrote up these examples with an example between for Ripon. So I have a lot of Ripon Good Cookies examples, and I wanted another firm. So it was like Girl Scout cookies. So it was my niece, and so that was the background. And then I switched this to be MP3s, and I didn't change the solution. So, all right, let's see. The inverse market demand for MP3 players is given by 320 minus 2Q. Firms served by two firms. Initially, both have a unit cost of C0. Find the price that each should set if they compete as Bertrand firms. Well, they should set their price equal to C0 as Bertrand firms. That's what Bertrand pricing does. Suppose one invests in innovation, reduces its unit cost down to 20. Find the new monopoly price and quantity. All right, well, as we said before, if this is the market price or market demand, marginal revenue is going to have the same vertical intercept, twice the slope. So it's going to be 340 minus 4Q is equal to 20. All right, so solving, our monopoly quantity is 75, and our monopoly price is going to be 170. For what values is a major innovation? Well, if we're able to undercut the rival. So the major innovation are those where the monopoly price lies beneath the initial marginal cost. So this would allow us to operate as a true monopolist if the initial cost was higher than 170. Suppose the initial cost had been 150, what happens? Well, now we can only set a price as high as like 149. We're not able to operate as a true monopolist. So we'd set like 150 minus epsilon or 149, and just we'd be able to undercut. We'd capture the market, but we wouldn't be able to force the other one completely from the market. All right, so here's another problem. So Ripon Good Cookies, Girl Scout cookies, all right, good. So suppose the inverse demand for cookies is given by 420 minus 1/3 Q. Initially, both produces at equal marginal or equal unit cost, C0. Find the price that each should set if they're competing as Bertrand firms. Bertrand predicts that price is equal to marginal cost. So we'd set a price of C0. Suppose Girl Scouts invests heavily in R&D, reduces its unit production cost to 70. Find Girl Scouts' new monopoly price and quantity. All right, so Monopolist produces where MR is equal to MC. So we're going to start off. Oh, whoops. So here was the market demand. So the marginal revenue is 420 minus 2/3 Q, right? So this should be marginal revenue is 420 minus 2/3 Q right here equals 70. This part's right. So 420 minus 70 is 350, 2/3 Q. And so 525 is equal to the monopoly quantity. If that's the monopoly quantity, the monopoly price is 245. For what values of C0 would this be a major innovation? Well, if initially the costs were higher than 245. So major innovations are those that allow the monopoly, or the monopoly price lies beneath the initial marginal cost. This allows the firm to operate as a monopolist. So price is equal to 240 is less than C0. Sorry, the monopoly price is 240. C0 would have to be is 245. The original shared marginal cost would be higher than 245 for this to be a major innovation. All right. What's the optimal pricing decision of Girl Scouts now that it has cost of 70? Well, suppose actually the initial cost was 220. The true monopoly price is higher than 220, so you're not able to capture the market as a monopolist. So you'd have to set the price of like 220 minus epsilon and just barely undercut the rival. Maybe you'd set 219 as your price or something like that. All right. Yeah, said that. Now here's another one. Good. Right, so here's the market demand, 420 minus 1/4 Q. Initially, both produces at marginal cost of C0. Suppose now Ripon Good heavily invests in R&D and reduces its unit production cost down to C0, or C1 is equal to 120. Find the monopolist's new monopoly price and quantity. Okay. Well, if this is my inverse demand, my marginal revenue is going to be 420 minus 1/2 Q. Right? Same vertical intercept, twice the slope. Set this equal to marginal cost, and then solving, we find our monopoly quantity, or monopoly quantity and then plugging this in, evaluating our market demand, right? Prices come from demand curves. So I'm going to put my monopoly quantity into my demand curve to find my monopoly price. Major innovations require the initial shared marginal or unit cost would be higher than 270, so like 271 or just 270 plus some epsilon. Major innovations are those where we're able to operate as a true monopolist, meaning that we can set the monopoly price and quantity. Suppose instead the initial starting point was C naught is equal to 200. What's the optimal pricing decision? Well, our monopoly price is going to get undercut by our rival because even though our costs are lower, they're still in the market. So our costs have fallen to 120. So their costs they still have costs that are lower than whatever would be the monopoly price. So we'll set a price just barely, maybe like 199, just barely undercut them. All right, elasticity and market structures. Consider the following market characteristics. We have market demand given by quantity is equal to 80 minus 1/3 P. All firms will have the same cost structure. Costs are going to be just given by 24Q. Find the price and quantity corresponding to the unit elastic portion of the demand curve. Oh, well, we just need to find the midpoint of this demand curve to find the unit elastic portion. So there's a couple different ways to do that. One is you could actually calculate the elasticity equal to 1, right? So the elasticity is percentage change in quantity divided by percentage change in price. So dQQ, the change is dQ. Dividing it by the initial quantity gives us a percentage change. dP divided by P is is the percentage change in price. This changes to dQ dP, which is a slope, times P over Q, which is price divided by quantity. I have a video on the calculus. So if you search for elasticity and find the calculus video, it'll kind of walk through this a little bit more detail. Anyway, so this is the slope. It's minus 1/3, right? That's the slope portion. That's the dQ dP. That's this part. Our P, we don't know that. Our Q is going to be 80 minus 1/3. Oh, this should be 80 minus 1/3 P here, right? And then solving, you find a quantity, or you find a price of 120. Referring back to the demand curve, we find the quantity is 40. So the profit would be 38.36. So the unit elastic portion of the demand curve. The other way you could do that is you could just find where's marginal revenue equal to 0, or where's the midpoint. Those will all give us the same value for the unit elastic portion. Okay, at what price would the competitive firm shut down? Well, we need to find the price below average variable cost. Variable cost is 24Q. Average variable cost is 24Q divided by Q. Average variable cost is 24. So price is lower than 24, the firm will shut down. Right? Compare the profit maximizing price and quantity for a monopoly. Okay, that's interesting. So if this is our market demand, right, let's make it, I think I'd rearrange it to be inverse demand. So let's solve this for P. So 1/3 is equal to Q minus, or 80 minus Q, or we have 240 minus 3Q. Here I have 240 minus 6Q. Why? Well, if the inverse demand is 240 minus 3Q, we want marginal revenue has the same vertical intercept, twice the slope, so that'll be 240 minus 6Q is equal to marginal cost of 24, and which we know because the derivative of the total cost is 24. So then solving, we find the monopoly quantity would be 36, the monopoly price would be 132, so then profits are 388.88. Let's see. Price equals marginal cost yields zero economic profit. This is if the market was competitive. Let's see. The smallest quantity comes from a monopolized market. That's right. That'll be over the elastic portion of the demand curve. The middle quantity is the unit elastic portion. That was this. And the largest quantity comes from the competitive market. It takes place over the inelastic portion. Yeah, that's right. So you'd have to draw the graph, and you'd see that the monopoly is producing at a point that's higher than the midpoint. Competitive market's producing at a point that'd be lower than the midpoint. Does the optimal production plan for the monopolist match your answer in part A? Why or not is this the case? Well, A is the revenue maximizing level of production. B is the profit maximizing level. So what the monopolist wants to do is they want to restrict output, and this raises profits. That's where profits come from. The monopolist restricts output. Here's another question, similar. So suppose the market demand is 72 minus 1/3 P. Here's our formula again for elasticity. It's the slope, dq dp times P over Q. Find the price and quantity corresponding to the unelastic portion. There's two ways to do this. One is you can use this formula. You could plug in the 1/3 and then P, and then the Q would be this right here. Set that equal to 1, and then you could solve for the optimal quantity. The other thing you could do is you could just find unit elastic is going to be the revenue maximizing point, and it's going to be the midpoint of the demand curve. So marginal revenue is equal to, let's see, so inverse demand is 216 minus 3Q. So marginal revenue is 216 minus 6Q. The unit elastic corresponds to the revenue maximizing point. Maximizing revenue, that's going to be, so we want marginal revenue equal to 0. When does this happen? Oops, did I do something clever or did I do something silly? So we want to maximize this. I think this should be a 6. Yeah, so anyway, so we'll find the unit elastic point is going to be quantity of 36. So the associated price is 108, and then the profit is going to be 108 minus 24 times 36. It's going to be 3024. Compare the profit and quantity for a monopoly and a perfectly competitive firm. Which of these correspond to the elastic and inelastic portion? I mean, you don't even need to do it. Like the monopoly is going to produce on the elastic portion, the competitive market as a whole on the inelastic portion. But to do this, you solve the monopoly problem. This is going to be the marginal revenue is equal to marginal cost. Solving, our monopoly quantity is going to be 32. Our monopoly price is going to be 120. Profits are 34.56. Price equals marginal cost is going to be 24 is marginal cost equal to the demand. This gives us a quantity of 64 at the market as a whole, price of 24, profits are 0. So the monopolist produces below the unit elastic quantity, below the midpoint. The monopolist produces above the unit elastic quantity. The monopolist produces a quantity lower than the unit elastic quantity, higher on the demand curve, right? On the inelastic portion of the demand curve. The competitive market produces a larger quantity than the competitive market, than the unit elastic and the monopoly, and therefore on the inelastic portion of the demand curve. This doesn't match the first part because the first part was revenue maximizing. Now we're interested in profit maximizing. All right, 35. Consider a monopolist with constant marginal cost of $2 per unit, no fixed cost. If the price elasticity of demand is equal to -2, what price must the monopolist charge to maximize profits? Well, we'll have this formula. Marginal revenue is equal to price times 1 minus 1 over the elasticity. Set this equal to marginal cost. So set this stuff equal to marginal cost. The marginal cost is 2. The output price was... we have to find the output price. The elasticity was 2. So we'll have P is equal to 1 minus a half equals 2. Find that the market price had to be 4. 36, a monopolist demand function and the total function, or total cost functions here. What level of output and price will profits be maximized? Well, so price times quantity is equal to total revenue. So Q times 500 minus 5Q. So revenue is equal to 500Q minus 5Q squared. Marginal revenue is therefore 500 minus 10Q. That's the justification for why marginal revenue would have the same vertical intercept but twice the slope. That's this right here. Okay, so we'll set that marginal revenue equal to marginal cost. What's marginal cost? Marginal cost is going to be 100 minus 10Q from 2 times 5 plus 1/3 Q squared. So we're going to have marginal revenue. We have marginal cost. And then, let's see, so we'll have, 3 times 1/3, that cancels, so we'll have Q squared. Yeah, that's right. So marginal cost is going to be 100 minus 10Q plus Q squared. Marginal revenue equal to marginal cost, that's this line right here. 500 minus 10Q equal 100 minus 10Q plus Q squared. Solving, we find our quantity has to be 20. With a quantity of 20, the firm produces or sells at a price of 420. What level of profit and price will total revenue be maximized? Oh, we just have to either maximize total revenue, so set marginal revenue equal to 0, or you have to find the midpoint of the demand curve. So total revenue is maximized when marginal revenue is equal to 0. So 500 minus 10Q is equal to 0, or quantity of 50 with a price of 250. All right. Suppose a monopolist faces demand curve of 12 minus Q, has no fixed cost and a marginal cost of 4. Find the monopolist profit maximizing output and price. Suppose the marginal cost rises to 6. What will the monopolist's new situation be? Well, if price is equal to 12 minus Q, marginal revenue is going to be 12 minus 2Q. Marginal cost was 4, so the monopoly's quantity is going to be 4. Monopoly's price is going to be 8. If marginal cost rises to 6, what changes? The marginal cost side, so now it's going to be 12 minus 2Q is equal to 6, or we get a quantity of 3, and we get a price of 9. So that's this right here. All right. Last one, inefficiency of monopoly. Suppose we have a monopolist who faces demand. Q is equal to 1,000 minus 20p, has marginal cost equal to 20 per unit of output. First, we have to get our inverse demand, so solve this for P. So 20p is equal to Q, or 1,000 minus Q. So P is equal to 50 minus 1 over 20Q. The initial production is going to happen where marginal revenue is equal to marginal cost. So if this is inverse demand, we go to 50 minus 2 over 20, or 50 minus 1 over 10 is marginal cost, or marginal revenue, set equal to marginal cost, which was 20. And then solving, we get a quantity of 300. And then once we've got the quantity of 300, let's send this back into our demand curve to get the price of 35. Now, suppose the government pays a subsidy of $10 for every unit of output to incentivize increased production. How does the monopolist respond? Well, this is going to change the marginal cost, so we'll reduce the marginal cost to 10. So marginal cost is going to be 20 minus 10 as a result of the subsidy. So we'll set 50 minus 1/10 Q equal to 10. Now the firm produces more. Get a quantity of 400, sells at a price of 30. How does this compare to the unsubsidized competitive market? Suppose rather than having a subsidized monopoly, suppose we just had a competitive market. Well, if we had a competitive market, production is going to be 50 is equal to 1/20th Q, right? The market demand equal to the marginal cost. We get a quantity of 600, and the market price would be 20. Right? So we'd get a lot more with a competitive market than we would with our subsidized monopoly. The idea of providing the subsidy for the monopoly would be to produce units that would otherwise not be produced, to minimize or to lower the amount of deadweight loss that's introduced as a result of the monopoly operating relative to what we would have if the firm was just competitive. So, all right, go ahead and conclude here. Hope this was helpful.